some basics about some angle relationships in triangles. So this is our first video together, guys. It's also our first video on triangles. Triangles are awesome. Here we go. So, first things first, we're going to classify triangles. We're going to do it two different ways. The first way we're going to do it is with angles. So, we all should know this. We should be familiar with this kind of stuff. We're just telling what kind of triangle it is. So we got our basics, we got acute, we got our obtuse. The acute has all the little angles, all the little acute angles. Obtuse, we got that one big angle right there in the corner. We got our right triangle. Our right triangle's got our one little right angle. And of course, there's the often forgotten that most people don't even realize even exists. We have equiangular, which just simply means equal angles. All three angles are exactly the same in this little triangle, thus the little arc mark deals. So, classifying by angles, acute, right, obtuse, and equiangular. Classifying them by their sides. Should be familiar terms again. We're going to start off with the equiangular triangle's cousin, the equilateral. Equilateral, equilaterals, or equal sides. In this case, all three sides the same. We have isosceles, two sides the same. Though technically isosceles means we have two sides or more the same. So equilaterals are isosceles. Most people just kind of stick with two sides for the isosceles. And then we have scalene. Nothing's the same on scalene. It's all sorts of any combination as long as nothing actually matches up. And if you put them all three together, you get a nice little jack-o'-lantern. See, yeah. In the spirit of Halloween. Woo! Right. Classifying our triangles. Moving on. Triangle angle sum theorem. It's exactly what it sounds like it's talking about. We got triangles, we have angles in those triangles, and we're going to sum them. We're going to add them. It says if a shape is a triangle. So any triangle it's going to apply to. Scalene, obtuse, acute, doesn't matter. The sum of its interior angles is 180. So if we take a triangle, here we go, here's a nice little triangle right there. I know it's not really that nice, but it's a triangle. We have three angles inside of it. See, 1, 2, 3. With those three angles, if I know two of them, let's say that this one up here is 80 degrees, and we got this one down here is 70 degrees. We can say, okay, 80 and 70, what do we have left? It's got to add up to 180. So I got 80, I got 70, I add them, that gives me 150, so I take that away from the 180, and I've got 30 degrees left. That 30 goes right there for our third angle. So we get 80, 70, I can use the 180 degree total to find a missing angle. Quick example, on your notes, you'll see we have this little picture there for you. I have a triangle right here, X, Y, Z. I'm missing the top angle of that triangle. I know a 62, I know a 40. I'm missing this guy right here. What is he? Well, we know they have to add up to 180. So I got 62, I got 40. Let's add those up, see how much we got so far. 62, 40 plus equals 102. We know it's got to be 180, so I'm going to take that 180. I'm going to subtract my 102. I got 78 degrees left. That goes right up there where that question mark was. Missing angle, done. It's 78 degrees. Moving on. Exterior angle, new vocabulary term. It's exactly what it sounds like. It's an angle on the outside. You see my little picture there? How the blue part is the exterior? Well, our blue angle, angle 4, is technically the exterior angle. It's an angle that is formed by the side of the polygon. Notice this little side right here. Here's our side. And the extension of an adjacent side. Side right next to it, keep going out. Boom. Angle formed on the outside, angle 4. It's exterior, it's an angle, it's an exterior angle. We have a theorem that goes with them. Exterior angles theorem. It says if an angle is an exterior angle of a triangle, so here we go, angle 4, exterior angle on a triangle, then its measure, or how many degrees it has, is equal to the sum. So we're going to add two things of its remote interior angles. That's a new thing, remote interior. We know interior means inside. Remote, that's a new one. Remote, well, I got one of those at home. It helps me control my television from the sofa. Remote literally means far away. If something is remote, then it is far away from everything else. So my remote interior angles are the angles on the inside that are far away. So here is my exterior angle. Its remote interior angles, well, it's not going to be 3 because 3 is right next door. It's a little neighbor. They can borrow sugar from each other and stuff. We're going to go with 1 and 2. So you can see 1 and 2, they're way on the other end of the triangle. They're nowhere close to angle 4. They are remote. They are far away. So this says I'm going to take the sum of those. So if I take angle 1 and I add angle 2, that should give me angle 4. It's that simple. Add up the remote angles, it gives you the exterior. How about an example? Let's do an example. I like examples. Here we go. Here's an example. I got a 5x minus 60. It's an exterior angle. See, it's on the outside. It's formed by a side and an extension. 5x minus 60. I have remote interior angles. I know that it's not going to be this little angle right there. That angle right there is not remote. That angle is right next door. They're neighbors. Angle B, though it looks really kind of close, is actually far away. It's not going to have the same vertex. So it's far away. It's in a different city. It's at vertex B instead of the vertex C. So we know that that's one of our remote, and then of course that 15 way on the other end is remote. It's pretty far away. So I'm going to take my 5x minus 60. 5x minus 60. And that should equal my 15 plus my 2x plus 3. Alright, I got some terms I can combine. I got 15, I got plus 3. I can combine those to get 18, so bring down my 5x minus 60, no change there. I got 18 plus 2x. Alright, algebra equation, I got x's on both sides, need them on the same side. Subtract 2x from both sides. I got 3x minus 60 gives me 18. Then I'm going to add 60 to get those 3x's by themselves. 3x equals 78. And finally, last but not least, divide by that 3. X is going to be 26. Done. If I really wanted to, if I was feeling ambitious or the problem asked me to, I could take that 26 and plug it back in. I'm not going to, though. It didn't actually ask me to do anything. I just assumed it wanted to solve for x. Next theorem, third angles. It is what it sounds like. It is a third angle, kind of like a third wheel kind of deal. Third angle. We got two angles of one triangle are congruent to two angles of the other. So we got, as you can see, L is congruent to R. It's right there. We know that M and S are congruent. So we got two angles of one. L and M are congruent to two angles of the other, R and S. Got that. If that, then the third pair are congruent too. So we got R and L are congruent, S and M are congruent. That just means that T and N are congruent. It's that simple. If you already got two pairs, they got to add up to 180. So that third pair has got to be the rest of the 180 for both of them. Let's do an example. Here we go. We've got two triangles that kind of overlap to make a little triangle in the middle, but I'm going to look at the big ones and ignore the fact that they overlap. I can see that F and I are congruent. They got the same number of little arcs. I can see that G and H, those angles right there, are congruent. They got the same number of little arcs. That's two pairs of angles. So that means K and J, K must also be congruent to J. K is congruent to J. That's not an equation because it's got a congruent symbol, but I know that K is 4y squared. Ooh, yuck, y squared. Well, we'll deal with that in a minute. Let me write out the equation. 4y squared, and that should be the same thing as J, which is 6y squared minus 40. Alright, 4y squared equals 6y squared minus 40. It looks gross. It's got that little squared on it. We're going to treat it just like if the squared was not there, and then we'll get rid of the squared at the end. Since I don't have anything but squareds, I'm just going to kind of get them all together first. So I got 6 on one side, 4 on the other. I'll subtract my 6y squareds from both sides. Cancel out. I get negative 2y squared equals negative 40. Divide by negative 2. Remember, I'm treating it just like it was a y. Doing the same thing I do elsewise. Get y squared equals 20. Last step, I got to get rid of that squared. I'm going to square root. That's the opposite of squaring, is square rooting. So the square root of y squared is y, and the square root of 20 is something between 4 and 5. I'm just going to leave it square root of 20 because it's a nasty long decimal.